Hello everybody, this is Cameron Snow, and in this video we're going to be continuing with our series on geological risking for exploration, and we're going to be talking about how we assign that probability to each hydrocarbon system component. And this is really an area that I've spent a lot of time on. And what you'll see as we go through this is you know, there are there's no right way to assign risk or to assign the probability of success to a hydrocarbon system component, but there are many, many wrong ways that we can assign that. And so what we're going to do is we're going to use a tool called risking frameworks to help us better understand how we can perform geological risking consistently. Because it's at the end of the day, it's probably more important that we are consistent than that we are potentially accurate. And the reason I say that is because without consistency, accuracy doesn't matter. It doesn't matter if you're perfect on one well if you're wrong on all the others. It's probably better to be systematically wrong than to be sporadically right. So let's take a look at a basic example to get started. So here we have an exploration prospect. So let's start off with this example. We have a prospect where we have a high side three-way closure. It's imaged on 2D seismic. It's overlain by a thick shell layer, and it's in a basin where there are many other producing wells. However, this well is in a fairly remote, undrilled part of the basin. Um, we've got seven 2D seismic lines that are defining the trap, and they have good vertical relief, and they're relatively high quality. Our sill analysis suggests that there's a high likelihood of shale juxtaposition. The source rock is believed to be present and mature, but there's not been any maturity modeling performed. Uh, and, we know from drilling this interval and our understanding of the basin that these rocks were deposited in a shallow marine environment. Um, and so the question is, how do we go about risking this? Well, so what we have is this table that came out of it, and there are three people that have analyzed this area. So we have our a generalist. He's a geologist that was brought in to perform kind of an independent assessment of this play. There was the area geologist who's been working this area for years and years and has very uh, in-depth understanding. And then there's the seismic geophysicist that was brought in because the seismic's so important on this play. So let's walk through the risk assessment that each of them has done. Our general geologist, he sees it's on 2D seismic, so he docks the structure a little bit. He's not quite as certain because it's on 2D. And he's equally worried about reservoir quality in this area. But the biggest concern for him is migration. And the reason why is several times throughout his career, he's actually gotten burned on migration. He has, he's drilled a well, where the structure came in, the reservoir presence was good, they had nailed the sill analysis, but it was in a migration shadow. And so he's a little cautious on that. Our area geophysicists, they're used to working on 3D seismic, but they think the 2D is okay. It's good quality. Um, he says that sill is never a problem out here, so he's not worried about it. And he says this interval always has sand deposited. Now, he has drilled some wells in here where the reservoir has been tight. And so he has evaluated that reservoir quality in this area is his biggest concern. Um, and, he, from his experience, has always seen that there is source rock that's both present and mature, and there's a clear migration pathway in here, and so has noted that there is put no risk on the source rock's presence and maturity. Now, the seismic geophysicist that's working in this area, she came in and she mapped it, and she believes that the seismic data is of sufficient quality that she can differentiate between the reservoir and the shell. She believes the sill is likely, but maybe quality is a little bit uncertain. She doesn't think that the seismic says anything about source presence and maturity either. So, she's looked at the offset wells and has assessed that, in general, presence and maturity is quite common. Um, but she thinks that maturity, because we've not done any type of modeling on that, is described as a coin flip. And so what we see are three varying levels of confidence here, where we see the generalist has given us about a 40% chance of success. The area geologist, he's quite confident and is given a 70% chance of success, and the seismic geophysicist is given a 31% chance of success. So the question is, how do we go about rectifying this? Maybe we could average out uh, each of their assessments. Or maybe we could take the midpoint of each assessment. So, 90% here, 95 here, 100, 85, 90, 80. And we could do something like that. Maybe that is a valid approach, and that would give us around a 50% chance of success. But the question is that the right way to do it? I'm going to argue that there is a better way. So I think what we need to do is we need to narrow the gap between each person's assessment. So for example, when we look at the biggest gap here, we see that it's on migration from a mature source kitchen. And we also see that the second biggest gap here is on source rock presence and maturity. So maybe what we should do is we should perform a study on migration and maturity to increase our confidence. Or maybe not, and by increase our confidence, I don't mean to increase the chance of success. I mean to increase our confidence on which probability is the most correct. So maybe what we can do is we can go in and we can look at all the offset wells and do a statistical survey on which ones have failed because of a lack of source rock presence or maturity. Or we can look at how many of the wells have encountered a source rock across the basin, and we can use that as a driver for what the risk should be here. If it looks like that source rock is essentially omnipresent, perhaps our area geologist is right. Or, if it's present 8 out of 10 times or 9 out of 10 times, and that's our maturity, we can use that. We can also do some modeling here. All right, maybe it's always present, but is it always mature? Are we at a much shallower depth or a much deeper depth and there's a chance of overmaturity? Well, that would maybe argue for, less than certainty, like our area geologist has put on there. Much along those lines, maybe we could do some simple migration modeling. It's a lot cheaper to do migration modeling than it is to drill the well. Hire a geochemical expert, have them do the migration modeling work, uh, narrow this risk. Do that before you spend tens of millions of dollars drilling an exploration well out in the frontier. And maybe by doing that, you're able to change the value here. Now, maybe it results in a lower overall chance of success, you know, uh, than we currently see, or maybe it brings this person's assessment closer to this, and it brings this person's assessment down, and so we end up with something maybe that is closer to that 42% chance of success that our generalist assigned. Um, so that is how we can go about narrowing that down. That is the type of workflow that we should use. Um, now that's fine when we have one prospect and three geoscientists. We can go about rectifying it for this one prospect. But what do we do if we've got 20 geoscientists that are working across five different basins, and you know, we've got 50 prospects? Well, this process can all of a sudden become very, very tedious. So what I want to do in that case is I want to set some rules. Um, so as we start to have multiple basins and plays and highly variable data, it's critical that we agree on a set of rules for establishing uh, risk. And that's what we're going to do moving forward. Now, I know what some of you are thinking. You're thinking, this isn't really a problem. I mean, this is a hypothetical example. So what I want to do is I want to reach into some of my recent experience and share with you. So recently, I was brought in to do a third-party evaluation of an exploration prospect, and this is what I was presented with. So it was a low relief four-way closure that was mapped on 3D seismic. It was fault separated from a producing field. It was at a slightly deeper stratigraphic interval than what was producing. Um, and it was all set by production to the east and dry holes to the north and south. The operator assigned a 92% chance of success. They essentially had this thing down as a development well. And the primary risk on this well, in their view, was the timing of migration. Um, so that was, they essentially viewed this as development. The partner on this, they viewed the primary risk as reservoir presence and quality. Uh, they had looked at the offset wells and they had said, the reason these offset wells weren't discoveries is because, the reservoir, wasn't present in one of the wells, and in the other well, it was of marginal quality. So they had significantly reduced the chance of success based on that, although they still had it as, a 48% chance of success, which in exploration terms is pretty confident. Um, and before they brought me in, they had their reserves auditor look at this, and the reserves auditor had put a 26% chance of success. Now, that makes it seem risky, but then when I looked at the reserves auditor had done, is they had taken a look at it and said, well, it's about an 80% chance on the structure and about 80% on sill and reservoir presence, and they had put each of the system components at 80% to come out with a 20%, 26% chance of success overall. I came in and I took a completely independent view, and I came in with something around 45% chance of success. So very close to what the partners had evaluated, much less confident than the operator, but a much more detailed analysis than what the previous third party had done. Um, and I came to this conclusion using a risk framework. So that's one of the things that you should always ask when someone presents you with a chance of success is, how did you get there? How did you come to this number? How did you come to the number on each of these? And a lot of times, people have a hard time telling you this. It's a gut feel for them. They come in and say, I've been doing this for 30 years. I know what it is. Now, that doesn't mean they're wrong. It just means that they can't articulate how they have gotten to that number, and they can't really guarantee you that they have consistently gotten to that number if you are looking at a number of exploration prospects. And this is what leads to variations on risk assessments between interested parties. So, this is what we're going to be, you know, trying to address. And I think the best way to address this is through a risking framework. And what a risking framework is it's a set of rules that dictate how we quantify the risk for each hydrocarbon component for any given exploration prospect. Um, so, what are some of the things that your risking framework will help you address? It'll help you address what is the data quality like, the type of data, and the abundance of data. There's a difference between, you know, 2D data and 3D seismic data. There's a difference between dense 2D data and very sparse 2D data. There's a difference between high quality and low quality 2D or 3D seismic data. So we need to take that into account with our risking framework. We need to understand what interpretations have been made. So revisiting our previous example, um, has maturity modeling been done? Your risking framework should take that into account. It should take into account knowledge from offset wells. Have we drilled any other wells in this area? What have the results been? Did we encounter reservoir? Was the reservoir of high quality? If we've drilled 10 wells in this area, within those 10 wells, in how many of the wells has reservoir been present? In how many of the wells has the reservoir been high quality? So we need to look at that. Um, and then we also need to take knowledge from analogous plays. All right, we know it is of this type of depositional system. Um, what does that tell us, when we think globally, when something is a shallow marine environment versus a fluvial environment? What does that tell us about the likelihood of reservoir presence and quality, and potentially source rock presence, things like that. So that is what a risking framework is going to help us understand. The risking framework that I'm going to be talking about here briefly is Alexei Milkov's risking framework. He published this in Earth Science Reviews back in 2015. I like this one because it covers each of the major risk categories. It considers data type and quality, and it was data driven. He developed this based on his long history of both academic and industry studies. So I think it is a excellent starting point for anyone who's just getting introduced to risking frameworks. And essentially, these risking frameworks are just lookup tables. So how do we go about applying these? Well, the first thing we need to do is we need to select the table that we're going to use. And in this case, we're going to look at structure. So let's say we're interested in evaluating the structure, so we select the risk table for evaluating our structure. The second thing we need to do is we need to identify the scenario. So in this case, let's say we have a medium relief structure, or a high relief structural with some structural complexity. Let's say a three-way trap. That's what we had in the example that we were looking at. And what is the quality of it? In the scenario we laid out, it's easy to interpret. And we have a reliable correlation, based on some nearby wells. And what we can do is we can say, okay, let's come in here. We've got this, and now we come to this line. Now, what is the type of data that we have available? Okay, is it 2D data? Is it 3D data? So in this case, if we have 3D seismic data, we would assign it to be an 80% chance of success based on what we outlined. So we just find that intersection. So let's rewind this, and we'll just go through a couple of other examples. So let's say we had gotten to this point, but instead of 3D seismic data, it was dense 2D seismic data. Well, we'd put a 70% chance of success on structure in that case. What if it's sparse? What if we only have 3, 4, 5 lines on here? Well, it's a 60% chance of success according to our risking framework. Um, so that is how we can do this. And these tables, they are. Just want to rewind here so we can read through a few of these things. The brilliance of these is not that this number is correct. You can't come here and say that yes, there's definitely a 45% chance of success based on the data and the type. But what it is doing is it is giving us a relative, explainable, and consistent way to assign that marginal probability. So that way, when someone comes in and asks us, how come you put a 95% chance of success on the structure? You can say, oh, well, the way I got here is this is a very high relief structure. It is, the offset on this was, let's say, 5 times the, our seismic accuracy. It's a nice, simple 4-way structure, so there's no complexity there. Um, but the one thing I will admit is, we're a little uncertain on the correlation because there's not been any wells drilled within, let's say 50 kilometers here. And so that's how we have gotten to this 95%. And as you go through these risking tables, you'll notice that, you know, there are uh, there are things that will, you know, make things higher risk, but you are more certain of that higher risk. And these tables can also, therefore, help you understand how we can de-risk things. So, for example, let's say we had, uh, very sparse 2D data and it is low relief. Well, it may be cost effective for us to come in and acquire a few more seismic lines across this to evaluate, you know, our structure. And so maybe you can go from something like a 5% chance of success to a 30% chance of success as you acquire more data. It could also be that as you acquire more data, um, you realize that there's more complexity. So actually, instead of having a you know uh, what you thought was a simple 4-way, maybe as you acquire more data, you realize that there is a fault in there, and you've actually gone from an 80% chance of success on what you thought was sparse data, but quite simple scenario, to now maybe you have dense seismic, but but you realize that the structure is maybe a bit more complex. Maybe there's some faulting involved. So you become more certain in your interpretation, but your chance of success goes down. And it's trying to capture these subtleties and balance, data presence, data quality, play complexity, uh, you know, trying to balance all that is why risk tables are so critical. And we've got these tables for each of the major hydrocarbon system components. So once again, I encourage you to go look up Dr. Milkov's paper on this. You'll be able to find this online. You'll be able to find screenshots of it. And make sure to use these frameworks so you can come to consistent and explainable answers on how you determined the risk. All right, I hope this was useful to you. And once again, if you're looking for a system that can help you ensure that you have uh, utilized risking frameworks and have made a consistent interpretation across all your prospects, once again, I'd say check out GeoRiskX. It is a excellent cloud-based platform for performing risk analysis. All right, thank you.